Today we'll be doing 5-5 direct variation. So you should have completed your activity already. If you haven't, you need to stop and go ahead and complete that direct variation discovery activity before you go through this section. As a review, every direct variation graph passes through the origin we hope you discovered. A direct variation equation takes the form of y equals mx. Y equals mx is thought of as y equals kx when discussing direct variations. So all they do is they take out your slope and they replace it with k. The variable k then replaces slope. It's called the constant of variation. Okay, so it's the same idea except for a different letter, and it's standing for the constant of variation. So now we simply want to look at these and we want to tell if they are an example of a direct variation. Why or why not. So if I look here, remember a direct variation is in the form y equals kx. This is in y equals kx form, so this would be yes. And y, it's in y equals kx. My next one is y equals x. Well, y equals x is the same as y equals 1x. So y equals kx. This would be yes. Again, it's in the correct form of y equals kx. Our third one here, y equals kx, but then it has this extra part. So this would be no, and the reason why it would be because that plus 1. On this next one, y equals negative 3x plus 0. The plus 0 part you don't really need, so this would be yes. And why? Because the 0 is not necessary. So you could rewrite it. Sorry if I spelled that wrong. You could rewrite it as just y equals negative 3x. Our next one is y equals negative 1x. Again, that's your k, so this would be yes, because it's in the form y equals kx. And our last one here, again, is no, because you have that plus 7 on the end. Okay, that should be a quick review. If we look down now below, example 1 is an equation, a direct variation. So in order to figure this out, you have to get y by itself. So to get y by itself here, the first thing I need to move, if I can get the pen to work, so I need a minus 5x. When I do that, you do it to both sides, you get 2y equals negative 5x. The opposite of times 2 then is to divide by 2. So we end up with y equals negative 5/2 x. And then it says, is it a direct variation? Yes, it is. It's in the form y equals kx. And then it says, if it is, find the constant of variation. My constant of variation is negative 5/2. And just like slope, you can leave it as an improper fraction as long as it's in the lowest form. My next one here then, I need to subtract 5x again from both sides. I end up with 2y equals negative 5x plus 9. I am going to divide by 2. So my equation is in the form y equals negative 5/2 x plus 4.5. So this one would be no, because of this 4.5. Example 2 then says, writing an equation giving a point. Write an equation of the direct variation that includes the point for negative 3. Well, we know our point is xy. We know the direct variation is y equals kx form. So I plug in y as negative 3, k times x, which is 4, and I have to solve for k. So the opposite of times 4 is to divide by 4. So I know that my k is equal to negative 3/4. Now that I have my k, I can put that in direct variation form of y equals k, which is negative 3/4 x, and there is my equation of the direct variation that includes the point for negative 3. Example number 3 says, your distance from lightning varies directly with the time it takes you to hear thunder. So directly means a direct variation. If you hear thunder 10 seconds after you see lightning, you are about 2 miles from the lightning. Write an equation for the relationship between time and distance. So my time is my x, my distance is my y. So I have y equals kx. They give me the time is 10 seconds. The time is my x, so I'm going to replace that with x. The distance is my y, which is 2. And now I just do exactly what we did in our last one. I'm going to solve for k. And I get k equals 1/5. And now I write my direct variation equation, y equals 1/5 x. Go ahead and turn the page. Example 4 is direct variations dealing with tables. So it says for each table, use the ratio y over x to tell whether y varies directly with x. If it does, write an equation for the direct variation. How they got this y over x is this. If you have y equals kx, you solve for k by dividing by x. So we have k will always equal y over x. So that's how they got that. That's why we're using that. And now we can go ahead and put this in your calculator or however you want to do it. Y divided by x, so you get negative 0.75. Negative 0.75 divided by 1 is negative 0.75. Negative 3 divided by 4, again, is negative 0.75. And our last one also is negative 0.75. So if I look here, our k, constant of variation, is all the same. So since our constant of variation is all the same, it says, is it a direct variation? Yes. And it says if it is, or if it does vary directly, write an equation for the direct variation. Sorry about that. So my equation would be y equals, my k is negative 0.75 or negative 3/4, however you want to write it, decimal or fraction, either way, x. So that is our equation right there. B then is going to be doing the same thing. We do y divided by x, which will give us our constant of variation. On this first one, y over x is negative 1 over 2. On the second one, it's 1 over 4. Automatically, I can see that these are not the same. So as soon as I get some that are not the same, I can go ahead and stop and just put, no, this does not vary directly. On our last example here, it says the force you must apply to lift an object is proportional to the object's weight. You would need to apply 0.625 pounds of force to a windlass to lift a 28-pound weight. You must, how much force would you need to lift 100 pounds? Well, I'm going to say x is my weight, and y is going to be my force. So, and it says it varies proportionally with it. So that means directly y equals kx. And it says here's the amount of force. So force is my y. So I plug that in for y. 0.625 is equal to k, which is what I'm trying to figure out, times my x, which is my weight, which is 28 pounds. So I'm trying to find my direct variation equation. So I need to solve for k. So I divide both sides by 28. And I get 5 over 224 is equal to k. Now I can write my direct variation equation as y equals 5 over 224x. And now I can use this direct variation equation to answer the actual question asked. How much force would you need to lift 100 pounds? Well, x is my weight, so 100 pounds, I'm going to plug that in as my weight. So I have 5 over 224 times 100 pounds. And when I do that, I get y equals 2 and 13 over 56 pounds of force. I would make sure you're working this out as you go and not just writing it down, so you can make sure that you know how to get the correct fractional parts in your calculator, just as a quick review. So now you can go ahead and complete the quick checks and then look at your schedule for your assignment for this section.